So we're told that P is the product of the integers from 1 to 30. So we're really just multiplying all the way to 30 inclusive. The question is, what's the greatest integer, k, meaning what's the largest value of k for which we can divide p, meaning this result is still an integer. We need to find the highest value of k. So really it rests on the prime factorization of the product of numbers 1 through 30. And it's if we were to decompose this into primes, meaning separate the 2's, the 3's, the 5's, and everything else, we just, the most important thing is how many 3's do I have. So you can either just count them out, list them all out, and if we look at the multiples of 3, they are 3, 6, 9, 12. This one is easy enough that you can list them out and count them. But they could ask you, instead of 1 to 30, ask you 100, 100 factorial, or 1 through 100. And I'm just going to count out. This is easy enough. So 1, 3 here, 1 here. I'm going to get 2 here. You do have to watch out for places you get 2. This is 1, 1. This is going to be 2. Because these are multiples of 9. And then that's, why am I writing 3? It's 1. This is 1. 8 times 3. There are 3 3's because this is 3 cubed. And this is 1. So all I have to do is to count this. 2, 4, 5, 6, 8, 9, 10, 13, 14. Let's see. Yep, it's there. Let me just make sure. 4, 5, 6, 8, 9, 10. Yep, so 14 is the answer, choice C. So that's, for this particular problem. But I just want to give you a general approach, which would be if the question was instead 1 to 100. One is not going to sit there and count these out. The strategy is you first count out all the multiples of 3. So you divide 100 by 3. And you're going to get 33. So there are 33 3's, single 3's, that come up as multiples of 3. But 3 comes twice in numbers that are multiples of 9. Like 9, 18, 27. Well, 27 is 3, but I'll come back to that. But if I count the number of multiples of 9 from 1 to 100, I divide 100 by 9. So there are 11 of them. Now I've counted the first set of 3's already when I did the 33 3's. So I get 11 more 3's in those numbers that are multiples of 3's. But then I also have to look for numbers that are multiples of 3 cubed or 27. Just as we found 1 here in 27. So we divide 100 by 27. 27 times 3 is 81. There's only 3. So we get 3 more 3's there. And then what about 4 3's? Well, 3 to the 4 is 81. That happens once. So we get 1 more. And 3 to the 5 exceeds 100. And just to kind of reiterate here, you're only counting the additional 3's. The first round counted the single 3's, and then this would be the 2 3's that are in multiples of 9, but we're only adding the one additional. So here, if I add these up, that's 48. So there are 48 3's, meaning 3 to the 48 would divide 100 factorial, or product of 1 through 100. So just wanted to kind of present the general approach in case you were asked problems with such large numbers. I fully anticipate the GMAT writers to do that, but those would be the harder problems. So to recap, the answer here is 14, which is choice C.